It seems like it is. And then I'll double check and make is right in the world. So today what we're going to do is we are actually going to write some MATLAB code to do the bisection method. So we learned about bisection method last time. We kind of talked a little bit about what we're going to do that. We're actually going to do it today. So first off, before we jump into that, I wanted to show you guys, I showed you the plot. I pressed this magic green button and I generated a plot, and we talked about this plot, but I didn't talk about the code behind the plot. It's not really anything earth-shattering. There's a plot command, but the one thing that is nice and that we haven't talked about yet is how did I generate some of this data. So the first part of this code, very straightforward. This is already on Isidore. But we generated a vector of mass values using the linspace command, so no surprises there. The part that is kind of different that we haven't talked about is what's going on kind of here in the middle. So what am I doing? What I wanted to do with this code is I wanted to give my Skydiver 0 function a whole bunch of mass values and get back the corresponding velocity 0 values. So to create that curve that I plotted. And so in order to do that, rather than putting my Skydiver 0 equation over here in this script, I just used the function that we already wrote. So we wrote the Skydiver 0 function in class together, right? It has inputs and outputs, and it has our equation for our velocity. We subtracted off our desired velocity value, and we got some sort of 0 value. And so we got our V0 value. Instead of putting all this code over in my script, I didn't want to, you don't want to have to reinvent the wheel that you've already created. We can just run our function from inside of our script. So just like we run a function in the command window, we copy and paste the first line, put it over in the command window. We can do the same thing from inside of a script. So all I did was I copied and pasted my top line of my function over here, put it in my script, and changed the inputs and the outputs into that function. So what am I doing with that function? Why do I need a for loop there?
You want to check all the masses in your vector.
Right, so mass is a vector, and I don't know necessarily if I set up my equation, my Skydiver 0 function, to handle a vector. Usually when we're doing root finding, that value is a scalar. We're trying to guess one mass value at a time. So I usually set up those functions to only work with scalar values. So I'm going to basically use my for loop to go through each mass value one at a time in my vector and calculate the corresponding V0 or velocity 0 version that comes out of my Skydiver 0 function. So just like functions, all other functions work in MATLAB, like linspace is a function in MATLAB, we can use our own functions that we write, like Skydiver 0, inside of scripts wherever we want to in our code. So just like we have the linspace function, we can use that. Somebody at MATLAB wrote that. We give it inputs and we get certain outputs. We can do the same thing with our own functions we write. We can give it whatever inputs we want, and we can back out whatever outputs that we want. So we can use our own functions just like we use all the other built-in functions in MATLAB. So questions about that? Anything? Okay. So now we're going to talk about the bisection method. And so I passed out your next in-class exercise. We're going to work on this today. We're going to work on this on Monday. So we're going to have all day class today, all day class on Monday. I'm going to give you, there should have been a second page to this. That was also part of Wednesday's technology disasters, was that I went to go make copies and it didn't copy the back side of this page. Page 2 will come on Monday. But right now you have page 1. That's all we're going to get through today probably. So what we're going to do in this in-class exercise is write our own function to perform the bisection method. So we've got the 5 steps that we outlined in class last time. How do we actually do the bisection method? And we need to write some code to do that. So what I want you guys to do for, I don't know, a couple minutes is just think. Don't start writing code, just think. What do we need to do to accomplish these steps in MATLAB? What kind of MATLAB code are we going to need to write to do these? So in our steps to write a MATLAB program, We've got our task list already. We're going to do MATLAB translation. So just kind of think about what code do you want to write to do these different things, and then we'll come back as a group and kind of walk through it, okay? So just think, talk to each other, and then we'll talk about it as a group. Is Facebook related to MATLAB? I don't think he wrote Facebook with MATLAB code though. Certainly not the bisection method. All right, so let's start with task number 1. So task number 1 says we're going to allow the user to choose two values, x1 and x2, such that fx1 is greater than 0 and fx2 is less than 0, or vice versa. So we've got a couple different things going on in there. Got a couple different things we've got to do in this task. So what's the first thing we should do in our MATLAB code? We need to do input, and that's going to let us choose the values, right? So choosing our values, this is going to be an input function, right? Now what did I say? I said we're going to write a script or a function for our bisection method. So should we be using an input in our function? An input argument, right? So because we're going to write a function to the bisection method, we're going to use an input argument. So we've decided how we're going to choose x1 and x2. We're going to let the user choose that. How are we going to determine if fx1 is greater than 0 and fx2 is less than 0, or vice versa? First off, why do we want to determine that? Why is that important? Why do we care? Yeah, John?
The root is at 0, so you have one on each side.
Right, because the bisection method is a bracketing method. We got to have two initial guesses. One has to be on either side of the root so that we can eventually make that bracket smaller and narrow down on the root we're trying to find. So we have to make sure that they've given us good initial guesses. Otherwise, our bisection method is going to blow up and it's not going to find the answer. So we've got to make sure that those are good initial guesses. How are we going to do that? How should we check these conditions? in a MATLAB code.
Run it on the function.
If statement, right? So we're going to need to use an if statement to check these things. What do we need to do first? You were saying something about the function.
Yeah, I mean, like check the x1 and the x2 whether it's positive or negative. Like
What are we checking? We're not checking x1 and x2. We're checking fx1 and fx2, right?
Yeah.
Where do we get fx1 and fx2?
The function.
What function?
We have like, for example, the skydiving.
Right, so for whatever problem we're trying to solve, whatever equation we're trying to find the root of, we have to use that to get fx1 and fx2. So we have our skydiver 0 function. We're going to use that to get fx1 and fx2. How do we write that in our MATLAB code? So if I say, we'll just call it fx1 equal to what? In my MATLAB code. I want to run my skydiver 0 function, right, to get that fx1 value. So just like I do in my command window, just like I showed you over here, we're just going to basically copy and paste that first line of our function into, first line of our skydiver 0 function into our other function. So we're going to have fx1 is equal to skydiver 0, and then what is my input to this function? x1, because that's the mass value that I'm trying to guess. I got that as an input argument, and now I'm going to give that to my skydiver 0 function. I'm going to get back out fx1, which is a velocity in the 0 form. That make sense? Same thing for fx2, right? Then we can write our if statements. We're going to need some if statements, right? What are our if statements going to look like? We have a similar thing for fx2. And then what's going to be in our if statements? If what? The fx stuff?
fx1 greater than 0, and then
So if fx1 is greater than 0 and fx2 is less than 0, so that takes care of this case. What about or vice versa? We said that was okay, right? We said it was okay to have fx1 be negative and fx2 be positive. It doesn't matter what the order of that is. So how would I write that? You could do an or, right? So we have an or statement, and I would probably put parentheses around that part, and then I would have an equivalent other part over there. Yes, sir?
It's not so clear. You change the mark.
Oh, can I change the marker? Yes. Throw this one away so that I don't use it anymore. So on the other side of my or statement, I'm going to have fx1 is less than 0 and fx2 is greater than 0, right? If that's the case, if that's true, what do I want to do?
Find the xm.
Find our xm, right? So kind of move along. What if I don't get a good initial guesses? What if somebody gave me 2 positive values or 2 negative values? What should I do then?
I think you need to change the x1 or x2.
We need to change them, and it's up to you how you want to do this. It's up to you if you want to put that into your code to make them enter it in again, or if you just want to, I don't know, make the code bark, basically, and move on and do something not the bisection method. So it's up to you. Huh?
Can I do it like as an input argument if it's like all of them less than 0.
So now we can't go back to our input argument because that's only a one-time deal.
Yeah.
So this is an exception to my input commands do not go in functions rule. This would be an appropriate place to put an input command inside of your function, is to get a new input from the user if they didn't give you the right inputs the first time. So it's an exception to my rule. All right. So if this is true, we want to do the bisection method. Else, make them give me some new inputs, maybe. Does that sound good? Questions about that so far? So that kind of takes care of task number 1. What's our task number 2? Task number 2 is to calculate our midpoint between x1 and x2. So what kind of MATLAB code do we need to do that? Anything special? No, just an equation, right? We just need to make sure we write the equation correctly. So we talk about task number 2. This is really just the equation. Easy. Then we get to task number 3. Determine if fx1 or fx2 have a different sign than fxm and keep the appropriate x value. So what do we need to do task number 3? Chase? Another if statement. So we're going to need to write another if statement. If something. What do we want to check in our if statement?
Similar to last time, but you have to, instead of like the first one, you have to change fx to fxm, and then have them both greater than 0.
Yeah, so we could say if fxm is greater than 0 and fx1 is greater than 0, right? That would be both of them are positive.
You have to say equal to.
Oh, equal to, right? Do we really need to say? I don't know. We might. We probably should, just in case we don't get ourselves in trouble. So we should probably have a greater than or equal sign in there. What do we want to do if that's true? If fxm and fx1 have the same sign, which point do we want to throw out? fx1 or x1? x1 by default also fx1. Same kind of thing, right? So we're going to do that. We're going to say, how do we do that? How do we throw out a point? John? Right. So we just set it equal to, right? We say, I want to get rid of x1, so I'm going to give x1 a new value. I'm going to set the new value of x1 equal to whatever xm is right now. I'm going to get a new value for x1. It's going to be equal to the current xm, whatever it is. I could do the same thing for fx1. Anything else I need to do? Fx, oop, yep, sorry. Thank you. Now what do I do about the other point? What if fxm and fx2 have the same sign? Do I need a new if statement? Do I need an else? Do I need an else if? What do I need? Else if? What do we think? Does it really matter? We could use an else. What would fall into the else category? I'm going to scooch over a little bit and do my else over here. What's going to fall into the else category? Any other scenario, right? We've covered ourselves. Chase said if it's greater than or equal to 0, and it's greater than or equal to 0, so if fx1 was negative, then that means hopefully fx2 is positive and it's the same sign as fxn, or vice versa. So we could just have an else. We don't necessarily need to ask another question, put another if here.
Why
We
are
could.
equaling x1 and x1?
This is replacing the points. So in task number 3, we said we wanted to throw out a point, right? So that's how we're going to throw out a point. Yes, sir.
What if they don't match?
What if they don't match? What do you mean? Like, what if neither one of them has the same sign as
Yeah,
xn?
because with the else, you're not only stating that if they're both negative or throughout this, but also if they don't match throughout this.
We've really screwed up if we've gotten into that situation, because that means that initially we got bad initial guesses, right? So we've already decided we've got good initial guesses. I don't think there's a situation that we could get in, if we have good initial guesses, that we wouldn't have something that would meet that condition over there. I don't think. I'll say that with like an asterisk. So I'm 99% certain that we wouldn't get into a bad situation. So I would just put an else here so we don't have to worry about it.
What if our fx1 starts negative? Because you said vice versa here. Like,
What if fx1 starts negative? So if fx1 is negative,
and so is fxm, then you still want to get rid of fx.
oh, maybe we do. Maybe, oops. Let me double check and make sure what I did. Yeah, maybe we do. So maybe we need to add an or? Can we do an or here? Or, and what would that look like? fxm is negative, less than 0, and fx1 is less than 0. We do need that. I forgot about that situation. Thank you. Right? So now if fx1 and fxm are positive, or they're negative, we replace x1. The other situation would be if fxm and fx2 match. Right? Signs. You good with that? Everybody? So what are we going to do in this else? Inside of our else statement.
x2 equal xm and if x2 equal fx.
Right. So x2 is equal to xm, and fx2 is equal to fxm. Do we need any other statements in there? We can just stick an in down there, right? So that takes care of task 3, right? What's task 4? Task 4 is to repeat steps 1 through 3. Maybe that should be just 2 and 3. That's a typo on my part. We don't need to repeat getting initial guesses. So repeat steps 2 through 3 until fxm is close enough to 0 as determined by our % error. So what are we going to use to repeat? What are our two options here? For and a while loop. Which one is appropriate for this situation? While loop. And why is a while loop appropriate?
When I approach to y equals 0.
Right.
So
But what's the difference? Why do we use for loops and while loops? What are the two differences? Kayla?
Because we don't know how many times we can repeat.
Right. So for loops, we know how many times we're going to repeat. We know we want to repeat something 10 times or 50 times. We don't know that in this situation. We don't know how many iterations it's going to take us to get to the root. It could be 2, it could be 1,000, it just depends. So we don't know that, so we need to use a while loop to do our repeating in this case. So if we talk about task 4, we're going to need a while loop. What needs to go in our while loop? Say that again? Second step and third step. So the code we wrote for steps 2 and steps 3 are going to go inside of our while loop. So I'm just going to write that as like a comment. Steps 2 and 3 go inside my while loop. What's my expression for my while loop? I repeat my while loop while this thing is true, right? And I stop when that thing is false. So what do we want to? We want to repeat until what condition? What did we say? Well, what did we say? We said it's dependent on the error, right? We said we want to repeat until it's close enough to 0 as determined by the % error. So we're going to determine when we stop based on our % error, which comes from that equation that I have there in the middle, the EA equation. That's our error that we're getting. So we need to relate our stopping criteria or repeating criteria, whatever we want to put in there, to that EA value. So while EA, we're going to call that, that's our % error that we're calculating, is greater than or less than something that we're going to determine is our tolerance. So when we do root finding problems, we have to tell the root finding method how close we want to get to the answer. We have to specify what that tolerance is. And in this class, I'll tell you what it is. I'll say solve it within 0.1% or solve it within some percentage. So we're going to have our EA that we're going to calculate in our code while we're doing the bisection method. And then we're going to have some sort of defined tolerance. And this will probably be an input into your function.
Why you don't calculate the error for each if statement, and then while it's running the while loop, when it's reached to a certain number, it will stop.
What do you mean? Calculate the error for each if statement?
Yeah.
Like
Include the error equation with the equation that we have in the while loop.
That we will, right? But we have two different things. We have like the current value of the error. That's what we're going to get from EA. That comes from that equation. We have to also specify the tolerance that we're willing to accept. We're going to solve the problem within 0.1% error. That's what this tolerance is over here. Does that make sense? We have two different, we have like current error and the desired tolerance error that we want to get to. All right? So what's this relationship? We're going to repeat while EA is what relative to the tolerance? Greater than, less than, greater than or equal to, equal to? Greater than. Why do we think it's greater than? Rose? you stuck your neck out there.
Yeah. Because you want, because if it's a greater % error, you want to keep going until it gets to that.
Right. So we want, remember our while loop repeats when this statement is true. So we want it to repeat when we still have a big error. We haven't gotten to the error tolerance that we want. We haven't found our root. When we found our root, then our error is going to be small and we can get out of the while loop, right? So we have a while loop. What do we have to remember about while loops? Can we just write while loops with while abandon? We have rules with while loops, right? What are our two rules with our while loops? Uh-oh, asking to remember something from weeks ago. Yeah, Greg?
One is like you have to be able to answer an answer.
You have to be able to get in, and you have to be able to get out, right? Those are our two rules, the basics of our two rules of a while loop. So how are we going to get into the while loop? Tolerance is going to be an input to our function. This is going to be, we're going to solve within 0.1%, so we're going to get that. What about our EA? Do we have to define that before we get to the while loop then? Yes. What value should we give EA? John? 100. It doesn't matter, right? Worst case scenario would be 100%. So I would, somewhere in your code, set EA equal to 100 before your while loop, right? That would just at least allow you to get into the while loop one time. I'm never going to ask you to solve a root within 1%, 100%. That would be terrible. So then how do we get out of the while loop? How are we going to get out of our while loop? Yep. EA becomes less than tolerance, so we've got to, somewhere inside of our while loop, calculate what EA is, right? So we're going to have to, somewhere in here, have EA equal to something. I'm going to leave that up to you guys to figure out. All right. And then that, I think, takes care of step number 4. Step number 5 is, this is the root. So what do we want to do with that? If we've written a function, what's the appropriate way to get that information back out to the user? Tell them what the answer is. An output argument, right? With functions, we don't put display. We do output arguments. So I'll do step number 5. We're going to use an output argument. And that's it in a nutshell. Now what did I do? I didn't write everything down on the board because now I want you guys to get to the point where you're writing your own MATLAB code more than me writing your MATLAB code for you. So this is going to be hard and frustrating, and I know that, right? I'm not doing this because I'm mean. I'm doing this because it's good for you. It's like taking your vitamins. You've got to learn how to do this on your own because I'm not going to be here to help you write your MATLAB code after the semester is over. So I'm leaving this a little bit ambiguous. And believe me, I know this is going to be hard for a lot of people. So that's why we're spending the rest of the class today and all day Monday working on this, okay? So, go. Conquer.